Okay, so now we're on page 4 of your third chapter 4 packet, 4.6 to 4.7. And this is page 4. And this says the graph of direct variation is shown. How do you know that this is direct variation? Well, we know it's direct variation because it's a straight line through the origin. Okay, so they want us to write the direct variation equation. Okay, so how do we do that? Well, first, we pick a point on the line other than 0, 0. So notice this point's on the line and it's 1, 3. And this is the x and this is the y. So they're basically telling us x equals 1, y equals 3. So how do you find the direct variation equation when you know x is 1, y is 3? You say a equals y over x. So a equals 3 over 1, which is 3. And then you plug it into y equals ax. So our answer is y equals 3x. Now that's one way of doing it. Also, another way you could do it is you could remember that a direct variation equation is the same as y equals mx plus b when b is 0. So because b is 0, I know a is going to be the same as m. So I could count up 3 over 1. I know the slope is 3, so that means a is 3. Just another way to look at it. Now, they say using your direct variation equation, which is y equals 3x, find y when x is 2. Okay, well, y equals 3 times 2, y equals 6. So when x is 2, y equals 6. Now, another thing you could do is we could count. We could say, well, this is when x is 2. What's y? 1, 2, 3, 4, 5, 6. Okay. So now I want everyone else, I want you to try to do this one on your own. Stop the video, turn it back on when you're done, and see how you did. So again, this says the graph of direct variation is shown. How do you know it's direct variation? I know it's direct variation because it's a straight line through the origin. They want me to write the direct variation equation. So I have to pick a point other than 0, 0. So that point is 3, 2. So I'm picking the point 3, 2, which means when x is 3, y equals 2. And I know a equals y over x. So I know my direct variation equation is y equals 2/3 x. The other thing I could say is since it goes through 0, 0 and it's direct variation, if I count the slope, which is 2 over 3, it's going to be the same as the constant of variation. So now I know y equals 2/3 x, and they want me to find y when x is 3. So I just substitute, and when x is 3, y is 2. Okay, now let's turn the page. And this is 4b. And this just gives us practice saying which equations represent direct variation. If they are direct variation, what's the constant of proportionality or the constant of variation? So remember, to do this, I solve for y. To solve this first one for y, I divide them both by 4, and I get y equals x. It's actually y equals x plus 0. So since b is 0, I know this is direct variation. And a is the coefficient of x, which in this case is 1. So for this one, I say 2y equals negative 3x divide by 2, divide by 2. I get y equals negative 3/2 x. It's plus 0, so I know it's direct variation. So my constant of proportionality is negative 3/2. Okay, so try the rest on your own. Stop the video, turn it back on, and see how you do. Okay, so number 3, I divide by 4, y equals 3x. My constant of proportionality is 3. For number 4, I subtract 7x from both sides, divide by negative 3, divide by negative 3, divide by negative 3. I'm already going to say, okay, look, there's no way this is direct variation because I end up with minus 4. B does not equal 0, so this is no. For this one, divide by 3, divide by 3, divide by 3. Y equals 4x minus 2/3. B does not equal 0, so no. Here, divide by 3, divide by 3, y equals 4/3 x. So my constant of proportionality is 4/3. For number 7, divide by 3, divide by 3, y equals 4x. That's a 4. Here, b does not equal 0, so no. Here, 2y equals 5x. Divide by 2, divide by 2. Y equals 5/2 x. This is 5/2. Here, negative 3y equals negative 7x. Divide by negative 3, divide by negative 3. Y equals 7/3 x. So this would be 7/3. Okay, so now let's turn the page. And this says, okay, the graph of direct variation equation is shown. Write the direct variation equation. Find the value of y when x equals 80. Okay, so we've done some like this before. So I'm going to pick a point on the line other than 0, 0. This is my x. This is my y. You can cross this out. We won't necessarily do it the way they do it. So we're going to say x equals negative 4 when y equals negative 3. I know that a equals y over x. So in this case, it's negative 3 over negative 4, or 3/4. So my equation is y equals 3/4 x. How else could I have gotten this? Because I know if it's a straight line through the origin, a is the same as the slope, and we can count up 3 over 4, and we get 3/4 x. Now we have to find y when x is 80, so all I do is substitute. 4 goes into 80 20 times, so the answer is 60. So I think there's a place to put that down here. So when x is 80, y is 60. Okay. So now direct variation is confusing at the beginning, but I think once we do it a few times, it does make sense. I do have to warn you, though, there's something about direct variation. You understand it today, you forget it tomorrow. So I want everyone now to try checkpoint number 3 and 4, and stop the video, do 3 and 4, and when you're done, turn it back on and see how you did. Okay, so this says graph the direct variation equation. Okay, well, that's easy because we know how to graph an equation from slope-intercept form. We say B equals 0, M equals 1 over 2. This is the rise. This is the run. So I start at 0. I go up 1 over 2, up 1 over 2, or down 1 over 2, down 1 over 2. That's my direct variation equation. Okay, the next thing says that the graph of direct variation equation passes through the point 3, -4. Write the direct variation equation. So I know x is 3, y is -4. A equals y over x. So y equals -4/3 x. And they want to know what y is when x is 15. So I cross simplify, that's a 5. So y is -20 when x is 15. Okay, so we're going to stop the video now.